All right, the first reported case of the deadly virus came in 1976, and it is named after the Ebola River in the Democratic Republic of Congo, which is where it was discovered. At the time, the area where the disease was spotted was officially recognized as Zari. The virus has since spread throughout the region. The spread in West Africa, it wouldn't have been as bad if it would have started in America because we have
more doctors,
more Germex, simple things like washing your hands could have prevented so many people getting it in West Africa where they're short of health supplies. But non-human primates like gorillas and chimpanzees have been cited by the World Health Organization as possible infection sources for humans. But experts have realized that they are not the source of the problem. The apes have been deemed accidental hosts, meaning that they catch the disease and then pass it along, but are not the initial reservoir source that produces the virus. How some people say, how would you get it from monkeys, chimpanzees? Well, say a monkey eats a mango or touches the mango that has the Ebola virus, then you put that in your mouth and eat it, and that causes you to get the virus in you. But anyways, that's how a human could catch it from one of the possible ways that a human could catch it from a different primate.
But also what they're saying here is that is when like the gorillas and chimpanzees have it, like they're not the main cause for Ebola.
Yeah.
At all. Okay, next slide. All right, this is a.
Can you click that? Can we click
on
that?
link?
It's got a bunch of pictures.
Yeah, go ahead.
So you can next one. Okay.
Skip this.
Okay, so
Here, I'll do the pictures when you explain.
okay.
Whoa. Okay.
All right, so what they're doing here is they're disinfecting this person right here.
The person in the white suit has been in a little tent that they have set up as a hospital with a person
That has
who has,
Ebola.
yeah.
Right. These are the symptoms of Ebola. This is a picture in Africa that shows you.
It's like vomiting, diarrhea, right there. I don't honestly that stomach pain. Does that say red eyes?
Yes, that's
okay.
and headache. All right.
That one is American troops that we sent in to help.
Building an Ebola treatment center.
Yeah, help organize that. Did we want to show anymore?
That's a dead body that they're carrying out. Someone who's died from Ebola.
Did we want to show all of them? Or
No,
just,
but
okay.
you can find out.
Let's do the last one or two more.
All right, let me see how long. Okay, this one is like nurses and stuff getting like supplies to clean down themselves.
All right, last one.
All right.
That's another dead body.
Yeah.
And then there you go. That'll be that.
And here's the graph.
This is the percentage of people that die from Ebola, 50 to 90. Oh wait, no. Okay, yeah, the percentage of people that die who catch Ebola is 50 to 90%. And then you have polio, which is only 15 to 30.
Lots of fever.
I think that's like a generic fever. I think.
That is it.
Okay, generic fever, which is 50%.
And malaria is 20%.
Yeah.
Less than or equal to.
Okay, influenza, which is your normal flu, only 0.1 to 0.3 die from that, which used to be a lot more deadly before we got the flu vaccine.
And here's the flu that's just seasonal, it's 1%.
Okay, next slide.
And here's another graph. This is the death toll, and this shows like HIV and.
That's I can't read it on here, but there's two different HIVs, and one is way less deadly than the other.
Okay, and then this shows Ebola up there, and it's around 70%. And then Chicken pox is 0%.
Another thing that's very deadly is rabies, which is 100% of people. If you get rabies, you're dead. So, I guess we don't have a cure for it yet. I guess we won't if we haven't by now, because it's been around very long.
I think we do, but you have to go to the doctor extremely fast.
Okay, well then, okay, so we have a cure, but
But most of the time, the people don't go to the doctor very fast.
Yeah.
So
you must have to get there. Okay, next slide. You did this one.
you did this.
Okay, Ebola virus causes severe hemorrhagic fever in humans and non-human primates, which may lead to shock, bleeding, multi-organ failure, and death since it first appeared in 1976. In two simultaneous outbreaks in the Sudan and Zaire, now the Democratic Republic of the Congo. Ebola virus has infected roughly 1,800 people and caused nearly 1,300 deaths, according to the World Health Organization. Ebola infection has a fatality rate up to 90%. There is no licensed treatment or vaccine.
Alright, next one. These are just our sources.
So you want slides?
No, I think that's
All right, very good. You're very thorough. I like thorough. All right, next set of volunteers, anybody? All right, we can get it. Tyler? Where is it? Did you guys share it with me? Oh, yeah. Thank you. Hop on my computer and get it shared. Not in.
Yeah, we already shared these.
And I
Like
should
three
have it
times.
here, but it's not showing.
We did like.
yeah, they already presented. You just didn't.
Funny.
You can just give us time.
No.
So in case you can do it.
Uh-huh. It's almost as funny as I look.
That's pretty.
Another volunteer?
Oh, thank God.
You still gotta go. Okay.
There we go. Have fun with it. I got kind of nervous when I didn't know how to pronounce any of those words.
Yeah, next time around, you'll want to make sure to practice those words.
Well,
Even if you mispronounce,
synonym for
right, even if you mispronounce them, if you can say them with fluidity, if you can say them smoothly,
no,
that's
no.
all right.
She knew how to say them, and she was good at it. I
Right.
had no clue what they were.
That's all right. All right, so we are getting these three. Wait. Why are all the computers on? Okay, you gotta share it, the rest of us should be all guys. Close it. Okay, thank you. Okay, hold on, let me get the names down. Okay, 3, 2, 1, go.
Okay, our topic was star types and formations. Okay, what are stars? Stars are luminous points in the night sky. And I put a picture of stars on my phone. It was really pretty. Go next one. And there's different types of stars. The red giants have low mass and they're near the end of their lifespan. White dwarfs are dying remnants of an imploded star. and super giants have a high mass, and they're near the end of their lives too.
Like up here, it just goes like the temperature is goes, I don't know, with the stars, the bigger they are, it's more.
Okay, you can go to the next one. And how are stars formed? They're formed under really extreme conditions. Like it has to be really, really cold. And at this temperature, gases become molecular, meaning that their atoms bind together. And how long would it take to get to our closest star? It would take about
4.2 million,
it would
like,
take 80,000 years traveling at 37,000 miles per hour because it's 4.2 million light years away. On the next slide, that's our sources. And on the next slide, we have a video, but it was slightly long, so I didn't know if you wanted us to play it or not.
Yeah, we're not gonna play the videos.
Okay.
All right. Apparently, someone knows how to clap.
So you already seen that. Seen ours. You can just use them.
No, sir.
So respond.
Still not seeing it here.
Look.
This shirt 3 times. I
Uh,
see it right there.
This,
no, down, right above mine.
who's mine?
Right, no, right there.
Oh, that's the problem. You didn't label it correctly. It's hard to see it.
Oh.
That's all right.
Come on up, guys. We'll fix this labeling problem that way.
All right.
Okay, hold on, let me get your names down. So far, you, the audience, you're doing great. Keep it up.
Hey, will you tell me how to grade it again? Or you take longer to grade it?
No, I won't know it till, later tonight or tomorrow. All right. Everybody ready? Computers off, devices down. 3, 2, 1.
Alright, well, that's a picture of the Ebola virus. Alright, you can go ahead. Alright, Ebola, previously known as Ebola hemorrhagic fever, however you say that. Ebola is a rare and deadly disease caused by infection with one of the Ebola virus strains.
It's not known for sure where Ebola originated from, but experts say the source is mostly bats. And that's where outbreaks are in Africa.
Or right there, not hard to see. So,
No, it's good. There's
that's
a
the video that we had. Not playing videos, so
Ebola is an outbreak virus that can never be stopped.
it's impossible.
What's your source for that? Internet. I'll need to figure it out later.
Our sources are right there. All right, and 6,548 people
No, it was 3 days ago.
a few days ago. So it's probably a few thousand more than that. Have died from Ebola.
Hold on, so over its 30-year existence, 6,000 people have died.
Since the outbreak.
Oh, since the outbreak. Okay, when was the outbreak started?
Like 6 months ago.
There's a chart that shows, well, you can read, it says that the red is death from cases of Ebola, and the blue is people that survived. It says all the years. Sorry, you can go ahead.
That's how you prevent getting Ebola or help prevent. We're currently going to Africa to help Ebola patients. And we are checking visitors from other countries, or if you visit another country, we're getting you checked for Ebola.
It attacks every organ and tissue of the human body except for the bones and skeletal muscles.
There's a picture that you skipped. Go back.
Go back.
The picture is just pictures of what can happen. Yeah, go ahead.
You can't read it. All right, you can go to the next slide. That's our sources.
All right, good. We have a question for you.
Hey, guys, so y'all were saying 6,000 people died in 6 months from Ebola. Y'all just said,
That's what it said.
Don't worry about
Wait, what? What?
good idea.
That's a legit question. As presented, you guys should be able to answer something like that.
Yes.
If the information's in your presentation, you should be able to explain it.
I did.
He
There's so many people died within since the.
Yeah, he was
Like that.
confirming that.
Oh, no, I said different.
Kind of. All right, who's next? So volunteer? Okay, you go yet? All right, on America? Yay. Not Ebola. Okay, well, hold on, I gotta get you for you. I'm not. But I do want you guys to come out, so we're good. That's a pretty insane claim to see the rabbits. Yes. Sure. All right, so we got, and talking needs to stop, devices need to be down. 3, 2, 1.
Okay, so we did ours over how the moon formed. Okay, so there are 4 to 5 different types of like theories about it, because we don't really know for sure, but we have a bunch of theories, and we only put 4 up there. And the capture theory is basically just like, the Big Bang happened, and there was rock, and then there was Earth, and it just kind of pulled into Earth's gravitational pull and just kind of started orbiting it. And then there was the other one underneath it, and that's where they were just kind of created next to each other, and they just kept themselves together. And the fission is how they don't really know how the moon would have like came out of the Earth, but it just kind of like broke off for some reason. And then the one that most people talk about is the ejected ring theory, which is where another planet like crashed into it, and like the Earth was just like a result of the debris of it.
The ejected ring theory is the most accepted theory in the scientific community. It was the Earth was forming, and it was like where all the lava and it was forming its crust, but it was still like really hot. And then like a planet named Theia, the size of Mars, came and crashed into it and like put debris everywhere and formed the moon eventually.
And that one's just over the capture theory. And just it formed somewhere else and just kind of decided to chill with it for a little while. I guess. Okay, go to the next one. But the reason, before we go to this, the reason we think that the ejected theory, why we think that one's the main one, is because whenever they looked through like all the stuff on the moon, they found like iron and stuff like that is in Earth. And they don't think for sure that the moon has like an actual, like a molten core. So they think that it just kind of like broke off from it.
cool facts about the moon was that it was created 4.5 billion years ago, a few hundred-ish years if you get to the exact after the Earth. So they were kind of all in the same pot.
And it actually has a lemon shape, and the reason they say that is because if you were to take all of the craters in the moon and just like fill them up, it would actually make like kind of like a shape like that. It's kind of cool.
It has earthquakes similar to not earth.
It has, they call them
Oh,
moonquakes.
moonquakes.
Yeah.
Milk.
That's so cool.
Just because due to Earth's gravitational pull, it drifts away from the Earth at a speed about 3.8 centimeters every year.
And once it completely like gets out of Earth's gravitational pull, we'll probably all die. So because it like messes with like the tides and stuff like that.
Not just it'll be on.
That'll be fun. And in the 1950s, the U.S. almost activated a nuclear bomb on the moon during the Cold War because they wanted to see how explosions worked in space. And Russia actually almost did the same thing, but the reason they didn't do it is because they decided that people probably wouldn't like that. And so they were like, you know what, we'll just put somebody on the moon instead. And that's how they decided to do the moon landing. And
These were videos. The first one was a video on like how the moon was formed, and the second one was how the moon was a lemon shape. And then the third one is like it's not even a video. It's like a virtual
thing, diagram type thing, and you play it, and it showed like the two masses and how the moon like collided into it.
Yeah, it's really cool.
Yeah.
Could we get that going?
It's the last one you said?
Yeah.
And then we have our sources, and that's it.
Yeah.
It's the last link on this slide?
Yeah.
Okay, go ahead.
What do you want me to click on?
Yeah, that would be the ideal.
I didn't know it was on.
And then you just press the little. It shows the moon colliding with Earth.
All that material over there just kind of like went like that, and that was a moon. And then it's where we're started, and that's it.
Very good. All right, Jasmine and Jericho. All right. Price is down. We're talking 3, 2, 1.
Okay, so for our midterm, we decided to talk about the galaxy. Next slide, please. And what is a galaxy? Well, a galaxy is a mass that is gravitational bound system that's filled with stars and gas and dust. And there is approximately 170 billion galaxies. There could be more, but we don't know yet. Because we haven't really, we only observed the ones that we can see. So there's probably more out there. Galaxies that have less than a billion stars are small galaxies. So if they have a million, they're small, they're not important to us, I guess. Oh, okay. The most known galaxies are the elliptical ones, and we'll go on about that later. And we live in the Milky Way galaxy, which is I think that's us, I don't know. Yeah, we live in the Milky Way galaxy, so yeah, next slide, please. Oh, no, go back, please. That's our video, but we're not gonna look at it yet, so keep the phone going.
How are galaxies formed? It is believed to have been formed billions of years ago after the Big Bang. There's a lot of theories, but we're not sure how it was formed. Some believe it was formed from collapsing gas and dust clouds under their own gravitational pull. And another theory is that it's formed from pumps and magnet. Some galaxies form from collisions with other galaxies.
The galaxies can collide.
The most, Okay, well, besides the elliptical galaxy, the other most common one we have is the spiral galaxy. And like, when I think of spiral galaxy, I think of like an octopus because they have like many arms and have like a center. So I guess it's like a little octopus thing. That's important. I don't know why I put that. That's not really important. 70% of the galaxies that we have observed are spiral galaxies. They are classified by how tight their arms are to the moon, so they're tight as a family again. They contain a lot of stuff. They contain a lot of dust and gas and stars and all that wonderful jazz. And new stars are formed in spiral galaxies. Fun fact.
This is elliptical galaxies known, and they are dimmer than spiral-like galaxies. They are commonly found in clusters of galaxies. M87, one of the largest galaxies in the universe, is identified as elliptical galaxy. Fun fact.
Oh, I don't know what happened to the other one, but there's another galaxy, it's the irregular galaxy. They don't really have any forms, and the way they are formed, that they collide with other galaxies, so they don't have any shape or form or anything like that. The galaxy that we have observed, 3% of them are irregular galaxies, and another fun fact is that there are some irregular galaxies that are called star bus galaxies, and like they're super shiny. Like I guess you can see them from anywhere, and I guess new stars are born in them in a short period of time. Yeah. Oh my gosh! Okay, go to the next slide. I'm gonna tell you how galaxies are old. Galaxies are mostly old is by gravitational and dark matter. Dark matter. Think of dark fission. Dark fission in the galaxy. Yeah, they're mostly held by dark matter, gravity, all that. So that's what keeps them together and going. I already talked about the radio galaxy. And that's our work site. And if you don't believe us, check that out.
Awesome. Thank you. Erica and Autumn, you guys have a source for the glowing the moon thing in your presentation by chance?
All of our sources.
It's in it? Okay, cool.
But like if you were excited.
Okay, cool. Yeah, I want to see that. That's pretty interesting. All right, who's next?
What was it?
That they were gonna test atomic bombs on the moon. I want to see. Huh? Okay, who's next? All right, so I'll start going down the list. See Jasmine, Logan, Ashley, Automerica, Jason, Chris, and Chase.
Yeah, not ready. Ready, Billy,
Okay. Number of slides doesn't matter. It's the content. Guys, it's not about how many slides there are. It's about the content that's on the slides. And the knowledge. If you answered the information, yes.
Then all of us were good. Oh, man.
All right, now ready? All right. Quiet down, devices down, computers closed. 3, 2, 1, go.
You want to go ahead and go on to the next slide? There's nothing really. Okay. What is the nature of science? The nature of science provides. I'm just giving a whole definition. I'm not gonna. It's not a real like normal sentence. This is just a definition. The nature of science provides key principles and ideas that provide a description of science and the way of knowing. Okay. Do scientific explanations change? Yes, they do. Scientific explanations change all the time. They change because of new evidence from observations. The reason they change is so that you can best understand something. It's like whenever you're going out to buy something, you think about it, you read the review about it, and then like somebody says something bad about it, and then you think about it, you're like, I don't know. And here's a whole diagram of how scientific, about how they really think, start, get an idea, perform the experiment. And if like something comes up, they got a bad idea, they go back. And then even if they have to go all the way straight down to the very bottom, they're like, ooh, yeah. And then revolution, they have to go all the way back. It's kind of a pain, but it's been a long. Did that say go to the next one? I'm not going. Even if like they're all the way at the bottom, they're just about done. Something messes up, they have to go all the way back. And I found this picture. It's a whole picture of like from space of the entire Earth and everything. Here's like, it looks like clouds. I wasn't real sure, but it looked neat. And I was just like, I'm going to stick this up here. It looks cool. And that looks like storm clouds forming over like the Atlantic Ocean, I think. And now you can put the next one.
Did you seriously want me to go back and talk about the clouds?
Yes, I did.
Hey, you're not criticizing the presentation, are you?
And these are the sources and everything. And,
Actually, go back to that, because that is a fascinating picture. If you guys look, okay, you see where the sun is, right?
Yeah.
So what's this right here?
Those are clouds.
Shadows of the clouds. So that can help. Okay, see that, you got the cloud right here, and then you got this dark mark behind it. That's the shadow of the cloud from the sun. And so that helps give you depth perception of how tall these things are. See this big clump right here, you can see the shadow take up a lot more space. That is a really cool picture.
The clouds melt.
No, they can evaporate.
Do we see the shape from the clouds?
Say what?
We should see the shape from those clouds. Since like we just get little glimpses of shade and patches, does look like it take a whole lot more space.
Oh, yeah. Yeah, and I remember when I was a kid, I used to wonder if the storms that were over me were how far out the clouds would spread. And sometimes those clouds, the storms will cover several states at a time. But if you guys remind me, I've got some really cool pictures of clouds that I can share with you from a guy on Pinterest.
Hey, I walked into a storm board and like you take one step here, it's dry, and you take one step and
Yeah, that's cool when that happens. All right, very good. Thanks,
Good job,
guys.
Chase.
We'll go next.
Yeah, great job, Chase.
Very proud of you. Very proud of you.
You got this.
No, I didn't. Yeah, we're just having What do you do?
All right.
I think
we messed up and put two
Okay.
topics in.
It's okay. It's okay.
Okay, so.
Hold on.
I
Not
got
ready yet.
Okay.
Nice.
Oh, we brought out the laser.
All right, computers closed, devices down. Remember, let's not be critical of presentations.
I
Yeah.
didn't say anything. He wanted to go back and talk about
And I have a
clouds.
keyboard. It was cool. You found it interesting?
Just press the space bar.
No, don't let them do
Did not go back a slide.
Yeah.
Should that,
Good job. And
does that go forward? That goes forward.
Okay, so, today our presentation is on speed of light and Ebola. Just go to the next slide.
The speed of light is a universal physical constant important in many areas of physics, and it was discovered by using a light source, a rotating mirror, and a stationary mirror. How that worked, I have no idea. We might, we might be able to travel the speed of light one day, but definitely no time soon, considering if we went speed of light right now, we would die, probably. And I don't know why I put that there. You can go on to the next slide. And this is basically tells you how long it would take to go from Earth to the moon at the speed of light. It would take 1.3 seconds, and Earth to the sun 8.3 minutes, and Sun to Pluto 5 hours and 40 minutes, and so on and so forth. And that's a video I found.
Okay, so now we're gonna do Ebola, and it's an infection that, of course, it can kill you. I'm just gonna read this. It's a general infectious disease marked by fever and severe internal bleeding spread through contact with infected body fluids, meaning if you're drinking after then, I'm not sure if sneezing counts. It just doesn't. And as you know, this is how the outbreak was. It started in West Africa, and it really, we didn't know about Ebola until it came to Texas, as y'all know, but everybody started freaking out. But as you know, it's a virus. It's taking many lives, more than 1,500 people's lives. And as you know, there's not a cure right now. Which is exciting. Why haven't we stopped Ebola? There isn't a predictable cure just yet. When they do find out you have Ebola, say you go to the doctor and they're just like, have you been out of the country in the last 3 weeks? You say no. If you say yes, they'll put you in isolation. They sit, for Fort Campbell, they sit, soldiers. And this is what isolation looks like. I couldn't find a good picture because of other stuff is blocked, but that's what isolation looks like.
So you'd be in that tent?
What?
You'd be stuck in that tent if you had Ebola, flying on a plane?
Yeah.
Okay.
That would suck.
And those are my sources. I don't know why that white thing is right there. Go to there's another.
Oh, there is?
There's one. Oh, there's this.
Sources, speed of light thing.
Yeah. And there's my video.
Okay. Very good, thank you.
Oh, there's some pictures.
Hey, I have a question.
So is,
You saying it's possible to go to speed light?
Light speed goes speed of light.
Yeah, it's in.
hey, Mr.
I was talking about us.
Video, yeah.
We haven't reached that.
I'm sorry?
We haven't reached the point yet.
Why don't we put a video we can use?
So I can watch
But that was like,
Alright.
my video is just a big part of it.
Hold on, guys, calm down, running out of time. You can't go speed of light, because the faster you move something, the more massive it gets, and requires more energy to move it faster. So, when you approach the speed of light, well, it's hard to do that
If I
anyway.
could just sit light, I could
The
get out of
fastest thing you have is what we put into space going 37 miles per hour, or 37,000 miles per hour. Right now, the International Space Station circles the planet at 17,000 miles per hour.
A real thing that'll cook your noodles. If you're traveling the speed of light, will you be able to see the light?
Yeah, that's one of the crazy things about it. Yes.
I'll tell you what,
Well, because, well, if we're outside, it's gonna, all of our skin's gonna get warm off. But if you're in the ship, then it's okay.
Just like that.
Like the cartoon animation.
Yeah, it's not, we can pull off your skin, but it's one hard on. I'm talking thousands of miles per hour. Okay. So weird. Right down, please. Right down. All right, so do we have another volunteer or continue on the list? All right, Devin, go ahead.
I think Gabe wanted to go. Gabe wanted to go.
Hey, he's going next. Guess the choice.
Are we gonna get Mr. Point stuff for not having a video?
No, I mean, it's just one component of it.
So that made it. Dude, relax, man.
Okay, I'm doing the formation of the moon. So.
All right, devices down, talking, 3, 2, 1, 0, go.
Before the big splash theory, there was the capture theory, which they just think that the moon just came from somewhere else and came in orbit with the Earth. But this, it's now failed because they found that there's not the iron source that there is here in Earth. So, and the isotope composition is insane. And then now we're stuck on big splash theory or the great something hypothesis. It was we found this out 4.5 billion years ago. Well, we think it happened 4.5 billion years ago. It was a planet-sized object that hit the side of the Earth, and some of the debris was trapped in the Earth's magnetic field, and later came all together to form the moon. And there's no video. I need giving a description of each.
All right, Gabe. All right, devices down, I'm talking, 3, 2, 1, go.
Alright, so my project was over the speed of light. The speed of light is fast, it's that quick. Next slide. How do we know the speed of light? They use lasers and vacuums to figure out the speed of light. We will never know the speed of light because it's not possible. The theory of relativity, that's Einstein, he said we couldn't. We use X-rays to see if bones are broke, and microwaves are used in microwave.
Okay, wait, what? Go back.
How do we use light in
Okay.
microwave? That's my video.
Is that one video?
Can we watch
Yeah.
that? Cause that's an interesting.
Yeah, it probably won't play, go ahead and click on it.
It says YouTube. So
It's YouTube.
or just click on.
No, the YouTube one.
All right, go back to it.
Yeah,
That's one way.
No, up to.
right there.
Yeah.
This gate.
And that's pretty great.
All right, next, Greg and Brock.
You can do it.
We got,
Here, I'll do
We got timer down here. No, it's not an alternate show. This looks familiar. All right. Devices down, I'm talking, 3, 2, 1.
We did the age of the Earth, and it said show proof that the Earth is older than 6,000 years. So this says people think it's 6,000 years old because of religious purposes, but science shows that it's 4.5 billion years old. And seafloor spreading is it's where this is an animation that shows it.
this one right here.
Yeah. And it shows how the magma comes up, and then it travels 5 centimeters per year, and it hardens, forming new ground. And I can go back to the slide. And yeah, so that and then we can determine the age or how old the ground is with the magnetic flip, and all that. So next slide. And in the Grand Canyon, the erosion is 3 to 5 millimeters a year, and the Grand Canyon's 1 mile deep, which means it's 16 million years old, and so that automatically shows that it's not 600 years old. And
to tell the date of the Earth, you can use radioactive dating. Just use the date rocks or carbon. It's usually based on a comparison between the observed abundance of an occurring radioactive isotope by using the decay rates of that isotope. Radioactive dating methods are used to establish a geologic timescale, and by establishing a geologic timescale provides crucial information on the age of fossils in the Earth. It is also used to date ancient artifacts.
And this is Pangea, and that's what scientists think all the continents look like a long time ago. And they moved apart 1 to 3 centimeters per year. So it takes billions of years to be where it is. This is not correct. Okay, never mind. But that's what you saw. That's it. All right, that's our works cited.
All right. I told you guys to look that up.
So you just said there's something not right. I don't know.
Who put this is not
I did. You did.
Oh, but you did
Because
that.
it's completely wrong.
Huh?
It's completely wrong. I told you to look it up.
We wouldn't have known.
Huh? Because if it's spreading at 1 to 5 centimeters per year, the distance between the continents wouldn't equal billions of years. It only equals 200 million years. Which is less than 2% of This I've done the research.
So what is it actually spreading?
The continents have spread for 200 million years.
So you're saying that the Earth is on 200 million years old?
No.
Oh,
I'm
you
saying
know,
that's
it
evidence that
only
it's
starts spreading 200 million years.
Right.
But it is 2 billion years old.
Hey, I just watched that chocolate thing. That's really cool.
What Earth was made.
What happened?
What?
All right,
If you do
they
not
put
get
this
the
chocolate
yours today, you will not be
microwave.
penalized. Just come talk to me and we'll work out the details. You're not gonna be penalized for not presenting today because of time constraints.
And then
Oh,
they
you
use
talked to
an antelope and they measured how long it was from the
Took
antelope.
my
All
new.
right, so talking down, devices off. 3, 2, 1, go.
We done ours over the humans some more. Next slide. How are we studying the surface of Mars? While robotic explorers have studied Mars for more than 40 years, NASA's path for the human exploration of Mars begins in low Earth orbit aboard the International Space Station. Astronauts on the orbiting laboratory are helping us prove many of the technologies and complication systems needed for human mission to deep space, including Mars. The space station also advances our understanding of how the body changes in space and how to protect astronauts' health. Next slide.
How long can the astronauts stay on Mars? It would take the astronauts 6 months to travel to Mars. They will also stay on the planet for 18 to 20 months. That's 2.5 years if they can stay on the planet. Next slide.
Yeah. Can we ask questions?
Not yet.
How would they get there? They would use Apollo, the same ship that took us to the moon, but they are worried about the cosmic rays that the sun gives off.
Oh my God.
What are the major obstacles of making it to Mars? One of the biggest obstacles is long-distance space travel is galactic radiation. Astronauts in the International Space Station receive samples that would exceed the lifetime limits, 18 months for women and 2 years for men. cosmic rays are unique types of radiation and they are difficult to shield against. And those are our sites. When the sun. I can't believe I missed something. That's so funny.
How long
Son. All right. Mr. Reed, come read your presentation.
That's me in the picture, by the way.
Oh, it is.
Yeah,
Which one?
this guy, of course. I'm not black.
Oh, is he black? I thought his face mask was just.
Maybe, I don't know.
All right.
What's this?
3, 2, 1, 0.
I had humans to Mars also. My stuff's not there.
There it is.
Oh, there it is. Some facts about Mars. Mars is home to the tallest mountain in the solar system. Out of 40 missions to Mars, not human missions, but only 18 have been successful, and Mars has the largest dust storms in the solar system. Why haven't humans been to Mars yet? I had a good video, but we can't watch it. But I got a little different information from them. It said it would take 8 to 9 months to get there, and they're basically unprotected on their way there. And the rays that the sun gives off, the radiation, if they come in contact with that, it could kill them. So that's one reason. And then, will humans ever make it to Mars? They think a mission to Mars is possible by 2030. They got to get some things worked out with their budget, and they are working on a mission to Mars to send 4 people there, and they want to live there for the rest of their lives. I don't know what they would do on Mars for the rest of their lives. They'll live in like little pods. So yeah, yeah, that's it.
It's okay. Well, that's okay. That's something that the spell checker won't catch, right? 'Cause it's the right spelling, just the wrong word. All right. So, Lori, is that the only one left? Jeremy and Nick, can you get the video to play? Let's try again. Got 4 minutes.
Why can't you just proceed?
Because I gave you guys the option. They chose to do video.
What is that?
I can't believe I misspelled all things. So.
I mean, you didn't spell it. You just looked at the word.
No, I didn't mean it.
Like, if you think about it, you literally didn't spell a word. You put a wrong word.
You put the wrong form of the word.
Yeah. I should have got a fun. We check. Yeah, you remember this again.
Tyler,
It is over.
you want to do it?
Do what? Gig it.
All right, last one. And devices starting 3, 2, 1, 0.
So if you don't know which time, I'll just run through it. You can go to the next one. My first disease of Ebola. Here's the symptoms right here. Fever, headaches, muscle pains, feeling tired, weakness. You bleed and bruise very easily. And after 3 to 6 days, you have vomiting and diarrhea. Can't say the word diarrhea. Well, right there, here's HWO. This is where I got information from for the symptoms. Go to the next one then. Well, the cases grew to very high heights, like within like a few weeks in December 2013, but it was not reported to the health organization, the World Health Organization, until March 2014. Next one. Well, it hasn't stopped yet. Well, in Canada, they have come up with a medicine for it, but it hasn't been approved yet by World Health Organization. It has been tested on monkeys, but not on humans. And here is where I got the information from for that right there. Next one. Here's all the cases. Most of the cases are right here. And this is a picture of Africa, but it's squeezed in, like zoomed in. And there's the next one. Here is a video of an Ebola clinic in Africa, but it takes 4 minutes. So do you have enough time? Yeah. And that's it.
All right, guys, you did a good job. Appreciate your efforts. Some of you put more effort than others, but that's still, you guys still did a good job. I'm not going to grade these super hard because we hadn't done any presentations in class, and I had forgotten that. So I apologize. We didn't have a chance to practice any of this stuff before you presented today. So I'm not going to grade very hard. But if you met the criteria, then you should be fine. Let's see. I don't know.
We got it.
I don't know. I don't know if I'll have these graded tomorrow or later this weekend, but we will get it taken care of.
So once you get done, you don't have anything else to grade?
Pretty much. You